Hello everyone and welcome to another installment of the IGCSE 0580 Solution Guide series. Today we will take a closer look at paper 2-3 from the October-November exam period of 2020. Without further ado, let's dive straight into it. In exercise 1 we should write down the cube number that is greater than 50 but less than 100. In order to do so we will just write down the first couple of cube numbers and figure out which one fits the requirement of being greater than 50 but less than 100. The only cube number for which this requirement is fulfilled is 4 cubed, which equals to 64. Exercise 2 is pretty straightforward. We are required to calculate this expression here, which we can do with the help of our pocket calculators, and the result that you should receive is 80. Next, over to exercise 3. Here we have a triangle ABC whereby the sides BC and AC are given. Using a ruler and compasses only, we should construct the triangle ABC. We should leave in our construction arcs, and the side AB has already been drawn for us with this one at the base of this triangle. In order to draw BC, with the help of the ruler we will measure a radius of 7.6 centimeters on our compass, insert the compass in point B and draw our construction arc. The construction arc needs to be above the base AB, since in every geometrical figure the letters of each corner are named counterclockwise. For AC we proceed similarly. We will measure our radius of 6.2 centimeters with the help of our ruler, insert our compass in A, draw our construction arc, and our point C is then determined by the intersect of those construction arcs. From there we simply connect C with A and C with B. Over to exercise 4. Here we should simplify the expression a squared divided by a to the power of 6, and we can do so with the help of the laws of exponents, which will be provided to the right hand side of the screen. So here just briefly, this expression accordingly translates into the expression a squared minus 6, which provides us with the result a to the power of negative 4. On to exercise 5. Thor intends to change 40,000 Icelandic krona into dollars when the exchange rate is 1 krona equals $0.0099. We should work out how many dollars he receives. In order to do so, we simply multiply 40,000 by the exchange rate, enter those numbers into our pocket calculators, and receive 396 for an answer. In exercise 6, we are provided with a triangle ABC. This triangle then should be reflected in the line BC to receive a quadrilateral ABCD. In exercise A, we should name this quadrilateral, and as we can see, this quadrilateral represents a kite. In a second step, we should find the angle ACD, which is this one here at the bottom, as this corner represents point D. To do so, we make use of the fact that all of the interior angles of a quadrilateral add up to 360. From there, we subtract 2 times the angle of 58, since the angle in A is the same as the angle in D. Furthermore, we subtract twice the angle of 82 degrees, since this angle over here is mirrored over there. After subtracting all of those angles from 360, we come to the conclusion that the angle ACD is 80 degrees. Next, on to exercise 7. Change 457,000 square centimeters into square meters. Here we need to keep in mind that 1 square meter translates into 100 square decimeters, which then translate into 100,000 square centimeters. So with every unit that we go down the line, we need to divide our original expressions by 100. So getting from meters squared to decimeters squared, we divide by 100, and to get there from centimeters squared, we divide by a further 100. After doing so, we can see that 457,000 centimeters squared translate into 45.7 meters squared. Exercise 8 is a rounding exercise. So here the length of L centimeter of the line is 18.3 centimeters, correct to the nearest millimeter. We should complete the statement about the value of L. So the length of this line must be less than 18.35 centimeters, as this 5 would mean that we would have to round up to 4, so it cannot be included into this interval. Similarly, 18.25 is the smallest number that can be rounded up to 18.3 if we were to correct to the nearest millimeter. Keep in mind that millimeters are represented by the first place behind the dot when we use centimeters. In exercise 9, we are supposed to work out this expression without using a calculator. We ought to show all of our working and give our answer in a mixed number in its simplest form. Firstly, we convert both of those mixed numbers into improper fractions. The procedure to be followed will be shown on the right-hand side of your screen. After applying the formula, you will get that the first expression translates into 8/7 and the second one into 21/10. 8 and 10 can both be divided by 2, after which we get 4/7 multiplied by 21/5. Furthermore, 21 and 7 have 7 as the largest common factor, so 21 divided by 7 then equals to 3, and 7 by 7 translates to 1. After all of the simplification, we simply need to multiply the numerators as well as the denominators, whereby we receive 12/5. As obvious, 12/5 is an improper fraction, thus we need to translate it into a mixed number, and 5 fits twice into 12, and 2 remain, thus we receive 2/5 as our result. In exercise 10, we are dealing with a simultaneous equation which we are supposed to solve while showing all of our working. So in the first step, we will rearrange the second equation for x, since all of the other coefficients are not 1. So it's always easiest to pick the one that has 1 as a coefficient, even though we cannot see it here. In a second step, then we can substitute x in the first expression for 4 minus 4y, and after doing so, we come to the conclusion that x equals 6. Now in return, in order to receive the value for y, we will substitute 6. This simply means we replace 4 minus 4y with x in order to determine the value for y. So firstly, we will expand this expression by multiplying each and every summand within the parentheses with 3. So 3 by 4 equals 12, 3 by -4 equals -12y, and the remainder we can just copy over. After that, we separate the y's from our numbers, and finally divide both sides of the equation by -20, and we receive -1/2 as a solution for y. In order to determine x, we can then substitute y for -1/2 in this expression over there, and after inserting it, we can see that x equals 6. So our solution is that x equals 6 and y -1/2. Exercise 11 states that a bag contains 7 red discs, 5 green discs, and 2 pink discs. In task A, it said that Helen takes 1 disc at random, brackets the color, and replaces it in the bag. She does it 140 times. The question is now to find how many times she expects to take a green disc. So replacing the discs and figuring out the expected times of taking a green disc gives us a huge hint on what to do. What we need to do is to find the expectation value for this event taking a green disc occurs. N represents the number of draws, which is 140, and P represents the likelihood of drawing a green disc out of the bag. We have a total of 5 green discs here, and the total amount of discs inside of the bag at any time, since we are replacing the disc after each draw, translates to 7 plus 5 plus 2, which is a total of 14. From there, we just put in all of those numbers into our pocket calculators, and we will see that the expected value for drawing a green disc out of 140 attempts equals 50. Exercise B expands further that Helen adds 9 green discs and some pink discs into the discs already in the bag. The probability of taking a green disc now is 2/7. Previously it was 5/14. Find the number of pink discs that Helen added to the bag. So we need to figure out our probability for drawing a green disc. The solution is 2/7 as stated here. She has added 9 green discs to the previous 5, whereby the number of the other discs has not changed. The only thing that we are not sure of is the number of pink discs that Helen has put into the bag, which will be represented by x. So now all we got to do is to rearrange this equation for x. So in the first step, we simply add up everything that needs to be added up. After that, we cross multiply the fractions on both sides of the equation. So we multiply 14 by 7 and 2 by 23 plus x. Afterwards, we isolate x to then finally receive that the value of x is 26, which means that Helen has added a total of 26 pink discs into the bag. In exercise 12, we have an interesting typo here. A straight line L has the equation, I suppose, y equals 5x plus 12, and in A we are requested to write down the gradient of L. So knowing that the general equation for a line states that y equals mx plus b, whereby m represents the gradient of the line, we can quickly see that the gradient for this line is 5. In B, we should find out the coordinates of the points where the line L crosses the x-axis. So for the x-axis, we should know that its functional representation is y equals 0. So we can then simply set up an equation stating that 0 equals 5x plus 12. In the second step, we isolate x, divide everything by 5, and then derive from there that the coordinates of the points where L crosses the x-axis is negative 12 over 5, 0. Moving on to C, a line perpendicular to our line L has the gradient k. We are supposed to find out the value of k as per the formula on the right hand side that shows us how to calculate the gradient of a perpendicular line. We derive to the conclusion that the gradient of that line is negative 1 over 5. In exercise 13 we have a Venn diagram, and we are supposed to use set notation to describe the shaded region, and we can see that the shaded region in this diagram consists of everything that entails B but not A. Thus our conclusion that this diagram represents an intersection of everything that is not A and B. Moving on to exercise 14, where we are supposed to take a closer look at the expression n equals 2 to the power of 4 multiplied by 3 multiplied by 7 to the power of 5. Pn should equal k, where p is an integer and k a square number. We are supposed to find the smallest value of p, which in return means that we are supposed to find the largest square number k we can derive from this expression. In order to do that, we transform this expression in this manner here, and this is for a specific reason. According to the laws of exponents, which will be provided with on the right hand side of this video, we are able to rewrite the expression 2 to the power of 4 and 7 to the power of 4 in the following manner. So this can be rewritten as 2 to the power of 2 squared, which is the same as 2 to the power of 4. 2 to the power of 4 is a square number, and a square number that is squared again becomes a square number as well. The same is the case for 7 to the power of 4, according to the same rules just explained for the case of 2 to the power of 4. What remains are the two factors 3 and 7, which result to 21, which is obviously not a square number. So the largest square number k that we can derive from n is 2 to the power of 4 multiplied by 7 to the power of 4. Thus our smallest value p equals to 21. Exercise 15 requires from us to make x the subject of this formula, and the best way to do so would be to isolate the root expression, after which we can get rid of the root expression by squaring both sides of the equation. After having done so, we simply multiply both sides of the equation with y, after which the exercise is completed. 16, we are dealing with a paperweight that has a height of 4 centimeters and a total volume of 38.4 centimeters cubed. And there's also a mathematically similar paperweight with the height of 7 centimeters. From there, we are supposed to calculate the volume of this paperweight. So what we are required to do here is to find a relation between the heights of both paperweights. So both pieces of information are given here, and we also need to express the relation for their respective volumes, whereby the volume of the paperweight needs to be determined. So the relation of the heights would be 7 over 4, and the relation to their respective volumes would be v for volume, since we are not sure of the volume of the second paperweight yet, divided by the volume of the first paperweight. We need to determine the cubed root of this expression, since the dimensions of the height and the volume are different. So we need to get the relations of the volume, which are represented in the third dimension, down to the first dimension. So the simplest way to do it would be to cube both sides of the equation, after which the cubed root disappears. And in a final step, we simply isolate v by multiplying both sides of the equation with 38.4. After using your pocket calculator, your result for the volume of that paperweight should be 205.8 centimeters cubed. On to exercise 17. Adil and Brian are paid the same wage. Adil is given a 7% pay decrease, and his new wage is $427.80. Brian at the same time is given a 7% pay increase. We are supposed to work out Brian's new wage. So formally, Adil and Brian have received the same wage, so this will be expressed by the variable x. And after Adil's wage has been decreased by 7%, which is represented by the expression 0.07, his new wage is $427.80. 1 minus 0.07 equals to 0.93, and after isolating x and dividing both sides of this expression by 0.93, we come to the conclusion that the previous wages were $460. So now that we are aware of their previous wage, we can calculate Brian's new wage, which has increased by 7%. 7% translates to 0.07, and after applying this formula, we come to the conclusion that Brian's new wage is $492.20. On to exercise 18. In A, we should simplify this expression, which can be done in applying the appropriate laws of exponent, which you are provided with on the right-hand side of your screen. So in order to calculate the power of exponent, we need to power each and every factor within the exponent. So we power 4 by 3, x by 3, and y squared by 3, which is done through multiplication of 2 and 3. 2 multiplied 3 equals 6. Finally, we simplify the expression 4 to the power of 3, which equates to 64. On to B, where we are dealing with an exponential equation. The exponential equation is 25 equals 125 to the power of k. And in order to find this, we need to apply logarithmic rules. So firstly, we are applying the natural logarithm on both sides of the equation. And by employing one of the rules for logarithmic equations, which you can find on the right-hand side of this video, we can transform the expression 125 to the power of k into this one here, k multiplied the natural logarithm of 125. Now we isolate k by dividing both sides of the equation with the expression ln25, and after putting all of those values into a pocket calculator, we are receiving the result that k equals to 2/3. In exercise 19, we are dealing with a diagram that shows the speed time graph for the final 40 seconds of a car journey. At the start of the 40 seconds, the speed is v meters per second. In A, we are supposed to find the acceleration for the car during the first 24 seconds. We need to remember that the acceleration is calculated in dividing the velocity of a vehicle by time. The velocity can be found by looking at the y-axis, whereas the time can be found by taking a close look at the x-axis. The speed of the car after 24 seconds is v plus 10, whereas the speed of the car at 0 seconds equals 2v. So in order to calculate the gradient, we simply need to employ a differentiation quotient. So we are subtracting v from v plus 10 and 0 from 24, as the gradient is determined by the delta of the velocity divided by the delta or difference of the time. After doing that, we can conclude that the car accelerates by 5/12 meters per square second within its first 24 seconds of its journey. In B, it is stated that the total distance traveled during those 40 seconds is 1.24 kilometers, and we are supposed to find the value of the velocity v. In order to be calculate its value, we need to justify the units. So we need to translate those 1.24 kilometers in distance into meters, which we do by multiplying 1.24 kilometers by 1000, since 1000 meters equate to 1 kilometer. Furthermore, we need to be aware that the distance traveled is represented by the area between the line graph and the x-axis, and the simplest way to do it would be to divide the entire area under the line graph into easy to calculate sub-areas. Area 1 is a rectangle, which area can be calculated by multiplying 24 with v. The second area consists of a right triangle, which base is 24. Its height is 10, since v plus 10 minus 4 equal 10. And finally, the third area also consists of a right triangle that comes by the height of v plus 10, and whose base is 16, since 40 minus 24 equal to 16. The way on how to calculate those respective areas can easily be determined by following the color-coded parts of this equation. So firstly, we calculate the surface areas one by one. Afterwards, we simplify the equation, isolate v, and divide everything by 32, which leads us to the result that v must be 32.5. In exercise 20, we are supposed to factorize the expression 3x plus 8y minus 6ax minus 16ay. So what we can firstly do is take a look at all of the parts of the expressions that contain x, which are these two. Furthermore, they not just only contain x, but actually 3x, since 3 is a factor of 3 and a factor of 6 at the same time. So after factorizing 3x, what remains is 1, since 3x divided by 3x equals 1, and negative 6ax divided by 3x equals 2a. Now we take a look at the remaining components of this expression. Firstly, we can see that both have the factor y in common. Furthermore, both expressions share the common factor 8, since 8 can of course be divided by itself, and 16 can also be divided by 8 exactly 2 times. In the second step, we see that both summands contain the same factor, which is 1 minus 2a, and after factoring this, what remains is 3x plus 8y. Thus, the result after factorizing the original expression is 3x plus 8y multiplied by 1 minus 2a. On to exercise 21, where we can find a representation of a sector. So OAB is the sector of the circle with the center O. The distance OB is 8 centimeters and the angle AOB 30 degrees. Furthermore, BP is perpendicular to OA, which means we have a right angle in P. In exercise A, we're required to calculate the distance AP. In order to do so, we need to firstly be aware that the distances OB and OA are the same, since both represent the radius of the circle, which means that AP must be 8 minus OP. In a second step, we need to determine the distance OP, which can be done with the help of this right angle here. So in order to determine OP, we need to calculate cosine 30 multiplied 8, which gives us the length of OP. And in the final step, we just subtract OP from AP, which is 1.07 centimeters. In B, we should work out the area of the shaded region APB, which is the area that is shaded in gray. So to get this, we need to calculate the difference of the area of this entire sector and subtract it with the area of the right angle. So step 1, determine the area of the sector, which can be done with the appropriate formula which you are provided with on the right hand side of the video, after which we should receive that the area of the sector is 16 over 3 pi. Secondly, we will determine the area of the triangle. From exercise A, we know the distance of OP, so all of the information that we have is the length of OB, the length of OP and the angle, which is 30 degrees. So here we can work with SAS, side, angle, side, and employ the formula that you can again find to the right hand side of this video in order to determine the area of that triangle. After all of this, we just subtract, as previously discussed, the area of the triangle with that one of the sector, after which we should learn that the shaded surface area is 2.895 square centimeters large. Moving on to exercise 22. Here we are provided with a table that shows information about the times in seconds taken by each of 100 students to solve a puzzle. And in A, we are required to calculate an estimate of the mean time. This can simply be done by the formula that is used to determine the weighted mean. So what we need to do here is to multiply the frequencies by the midpoint of each and every interval. So here it's 9 multiplied by 5, since the distance is 10 and the midpoint would be 5. Then we add to this 18 multiplied by the center of this interval. In order to calculate it, we could simply subtract 10 from 15, and the halfway point of this interval is 12.5. For the rest of this calculation, we are doing the same things over and over again. After putting in all of those values into our pocket calculators, we will derive to the conclusion that the mean time for solving puzzles for this group of 100 students is 27.625 seconds. In B, a student by the name of Emmanuel draws a histogram to show this information. Below we have a table that shows the heights in centimeters of some of the bars of the histogram, and we are supposed to complete this table. The information that was previously not given was that for the height of the interval between 20 and 40 seconds and the height of the bar for the interval between 40 and 75 seconds. So in order to do that, in the first step we need to determine our multiplier, which can be done by dividing the time interval with the frequency, which we can then multiply by its height. In a second step, we will use this equation and rearrange it for the height, since this is the value that we need to determine for the final two intervals. So just to be safe, we are applying this formula for all of those three columns. Just to be sure that our calculations are right, we should always receive the same result, which in this case is 4. And after having found the multiplier applying this formula, we can find the missing heights of this histogram. Moving on to exercise 23. In this exercise, it's stated that y is inversely proportional to the square root of x when y equals 7 and x equals 2.25. We're supposed to write y in terms of x. Since y is inversely proportional, we firstly need to put the argument into the denominator. Furthermore, we need to find the square root of it as per the description of the exercise. With the help of the values that are provided in aforementioned exercise, we can determine the value of k by rearranging the equation for k. Inserting the values into our pocket calculator should tell us that the solution for k is 10.5. Therefore, we can substitute k with our newly found value of 10.5. Thus, y equals 10.5 over the square root of x. In exercise 24, we are required to simplify this expression. So firstly, we take a look at the numerator, and we should be able to see that we can take advantage of the binomial formulas, which you are provided with on the right-hand side of the screen. Furthermore, looking looking at the denominator, it should be clear that the best approach to factorize this expression should be the application of V8's formula, which you're also provided with to the right of this video. As we can see, the numerator and denominator consist of the same factor, which is x minus 5, and after simplifying this expression we are left with the expression of x plus 5 over x minus 12. Finally, with exercise 25 we have arrived to the final question of this exam paper. Here we are supposed to solve the equation 3 tangent x equals negative 4 within the interval of 0 and 360 degrees. Firstly, we will simplify this equation for tangent x, which is simply done by dividing both sides of the equation by 3. Furthermore, since tangent x is negative, the solutions can be found in the second and fourth quadrant. Using our calculators, we should receive negative 53.13 degrees as our first result. Here we need to keep in mind that this solution is certainly not correct, but it's just a step in order for us to figure out the first angle in the second quadrant. To do so, we subtract this value from 180, and as previously mentioned, our second solution can be found in the fourth quadrant, and in order to do that we subtract 53.13 from the full circle, which leads us to the solution of 306.87 degrees. I've been your host Marco from PlanetMaths. Should you derive any value from my videos, please consider to leave a like, comment and subscribe. Thank you for watching. Cheers!